sort of trying to oh, fantastic, thank you. I had forgotten to record this, so that will help. So here's some general elements that you should consider as you're asking yourself what program to join. So there are many considerations. You should consider the topic, the sort of the general field in which you're working. I'll say a little more about differences between different types of programs like master's and PhD programs. If sometimes you're interested in either a general topic of research, perhaps a specific topic of research, maybe the research of an individual, right? So maybe you've heard someone give a talk and that made you excited about working in a certain area, perhaps with a particular researcher. Those can be considerations in finding a program. That can sometimes make the decision easy. It is still generally good to perhaps search multiple programs and find your own, find options, because sometimes the person you most want to work with is not available for one reason or another. You should consider costs, including costs of the program itself, costs of if you're moving to a new city, considering what kind of financial support you're getting through the program and what the cost of living would be in those conditions. There might be geographic considerations, places you'd rather live, places you prefer not to live in, being afraid of earthquakes or something and not wanting to go to California. You should consider many of these elements, and we can go into details, especially if you have questions on this. Let's start first with kind of a broad distinction. I mean, the graduate school comes into broad flavors. One is a master's program and the other is a PhD. And the master's itself can take more than one form. So usually a master's program is short, and it can be a good way to try out whether you're interested in doing a PhD, because it doesn't require the longer term commitment. And if you're not 100% sure whether you want to do research, a master's can be a good way to try it out and then decide whether you want more than that. Depending on the program, you may have more or less research components to this. Usually you take some classes. Some master's programs are very class intensive, so you would take a rigorous targeted course program. Some of them would then have research, and if you and within the masters that involve research, you would probably be encouraged to complete a master's thesis, which is sort of a way to have a product of this research. One limitation of master's programs, or one difficulty with master's programs, is that they're typically not funded, in the sense that you don't get the stipend, and you often don't even get tuition waivers. So they're often more expensive. So even though you're only in the program for 2 or 3 years, sometimes even shorter. There are some master's programs that can be quite short. Usually you have to pay to attend those programs, and the options for support can be relatively limited. PhD programs are longer. They don't typically require that you have a master's. Having a master's doesn't hurt, and sometimes is a plus. Like if we see a candidate that has done a master's, especially a master's with research, that gives us some confidence that that candidate is well prepared. They've already done research. Maybe they already have a paper, or they have a thesis that they can show. I did this research. So often a master's can be a plus, especially so sometimes students might feel a little insecure because maybe their GPA from undergraduates isn't very strong. If they've done a good master's, with good coursework, that can be a plus. Masters can also be good if you're planning to do a PhD in an area that's in which you're weaker based on your undergraduate degree, like maybe you do. So I can think of, imagine something, maybe you've done a biology degree, but it was sort of more based on ecology and evolution, and maybe you want to shift more towards cell biology, biochemistry. Doing a master's that addresses some of those gaps in your preparation can be a plus too. But as I said from the beginning, it's not required to do a PhD. It's completely fine to apply directly to a PhD program. If you're convinced that you want to do research, it's perfectly fine to apply straight to a PhD program. So usually it's longer. In the US, it's typically, 5 years is normal. Some students can finish a bit faster than 5 years. Not often faster than 4. It's possible, but it's not common. 4 would be reasonably fast in the US. 6 is not uncommon, so 5, 6 is not uncommon. Longer is also possible, but less common, perhaps, especially in the sciences. You usually also take courses, and this is one point where it's good to think of considering programs in detail and looking at what the requirements are, because different programs will have different course loads. For example, I understand that physics in our department, here at UH, physics until a few years ago had a very, very heavy course load for PhD programs, and they've reduced it a little, but it's still kind of heavy as far as I can tell. I mean, certainly compared to the programs in biology. Yeah, and the programs in biology. Go ahead, Greg.
Specifically, we required 4 courses beyond the average in the United States as of 3 years ago, or 4 years ago, and we reduced that down to now just 1 more than average. And so we're still
kind of average.
Pretty sure it's 1 more than average. We're still pretty tough, but we're at least not quite as bad as we were.
So this is, and so this is something to. This is just to encourage you to. It's good to look in detail at what the programs require. One reason that just occurred to me where it's useful to do that is why it's useful to do that is sometimes programs can have names that are designed to attract attention. But you need to be sure, especially the more interdisciplinary programs, you might see a program that says, computational biology. But then it's worth looking in carefully at what is this computational biology program? Is it just a biology program with a few computer scientists in it, or some people who do computation? Is it a computer science program with a few people that have vaguely biological interests? Because those can be very different kinds of programs. And so looking at who are the faculty, what courses are being taught, what courses are required by the program can give you some insight into what's going on in these programs. So this is kind of spelling out some components of this. So these programs often then have a qualifier process. So you enter a program, and for a couple of years you're, let's say, probationary, and then you're in a probationary period, and then you take an exam that can take many forms that then qualifies you to finish your PhD. So usually the first couple of years you take a lot of classes, and then you take this exam, and then you're mostly doing research for the rest of your PhD, maybe about 3 years. Although details will vary, and it's worth finding out in detail what particular programs are like. Typically, PhD programs in the sciences are funded. So that means, so for example, I just as an example that is not atypical, programs in the sciences at U of H, PhD programs, you receive, you pay tuition and fees, but you receive a fellowship that covers the tuition and fees. Right? It seems like an odd way to do it, but that's for technical reasons. We can't just waive the fees, but in practice, you're not paying fees. You pay like the rec center fee and some small things like probably less than $100 in total for fees, and you don't pay tuition, and on top of that you receive a salary. This is typical of science PhD programs around the US, and so that's a consideration. It's like having a job. You do research, you do some teaching. One of the options of being funded is to do some teaching. There's a slide coming up where I'll explain that in more detail. But it means you're funded. You're not paying for your PhD, except to the extent that maybe if you're doing a PhD in a very expensive place to live, you might need to borrow money to cover your costs, but you are being supported to some extent by the program. And the next slide will tell us more about teaching. So usually when we say funding, it can come in two ways. For example, in our this varies between programs at UH, for example. But I'll just give you the example of the biology and biochemistry department, where we have different graduate programs. There, whether you do a teaching assistant or whether you're a research assistant, you get paid the same. The difference is, as a teaching assistant, you have some teaching duties. And as a research assistant, you just have to do research. Sometimes the research might have constraints imposed by your mentor. Your mentor might say, well, I'm going to pay you this semester to do this research, but by the way, you have to do this thing here that is because the grant, you have to do this work because I got a grant to do this work, and you have to do this work over here, even though it's not directly your primary research. So in that way, it can be similar to a teaching assignment. It's an assignment to do something. And so the idea is as a TA, you might teach a lab class or teach a recitation class. Typically, you have up to 20 hours a week worth of work, although we try, for example, in biology, we try to make the workload less than 20 hours. The limit is 20 hours, but we try to make it closer to 10 or so. As a research assistant, you typically get paid by a mentor from grant funding that they have in their lab, but usually the support is about the same either way. And it's common. It depends on the program. So in some programs, in some areas, there's relatively little teaching money, and so you might join a program with the understanding that you have to be you have to work as a research assistant. In fact, you can think about it from the perspective of faculty. The program will only recruit enough, as many people as can be supported by faculty, right? So in some programs, it's like that, and so you pretty much do research. In other programs, there's more flexibility on the teaching side. For example, biology, biochemistry here at UH, we teach these large lab classes, so there are quite a few teaching positions, and so we can have a few extra students that are supported mostly through teaching. So either way, these are ways in which you can get funded, and it's perfectly okay to try and interrogate the program to some extent over how does funding work at the program, right? And certainly so when I said in the previous slide, typically the programs are funded. It's important to see what does the program say they're going to do, right? When you get an offer, what is the offer? Are they guaranteeing support for the duration of the program? Are they guaranteeing support for 5 years? How does it work? Some programs are less clear than others, and so it's good. Once you get an offer, it's good to make sure that you have a commitment for support for the duration of your program, if you're comparing different programs. Okay, so this is sort of general advice that you should do some research in advance. I mean, it's kind of going back to a couple of slides ago when we were asking, so how do you choose a program? You know, one of the, we keep coming back to this, that you have to do your own research to some extent, right? You have to find out more about the programs, look at what courses are being taught, what faculty are there, what are their research interests. All that is important because sometimes, you know, sometimes you might want to apply to a particular program because there's one person there that you're very interested in. But it's worth knowing what the rest of the department looks like, because you're likely going to interact not just with that faculty member, but with other people in that department. And it's often a good idea to apply to a program where many people are doing research you're interested in, not just one person. You know, not least because you might be accepted into a program, but it's not immediately, you know, it's not always guaranteed that you're going to end up having the ability to work with the person you're targeting in advance, right? So it's good to figure out what people are doing. So here I'll just throw in I'll make one quick comment on this that it sort of intersects a little with perhaps something that Greg will talk about later, but I'll just mention it now. One general piece of advice is don't just believe whatever's on the website of a faculty member. And what I mean by this is, and this can take, you know, even a website that's well maintained and that has that's been updated relatively recently, by no means guaranteed, right? I can't remember the last time I've updated my website, you know, I'm ashamed to say. But even when that's up to date, like you look at the website, like, and you can see, oh, there are these 3 projects described, and there are these papers published in the last 3 or 4 years. So it gives you a sense of what this lab is working on. What will often happen is the research that's most cutting edge, most interesting to the lab right now is not on the website. I can pretty much guarantee you that. So my advice is, if you find individual researchers that seem to be doing interesting research to you, so like, oh, this I'm interested in this, you should then try and contact them and see and find out more. You know, if you're thinking of applying to a program, it's perfectly okay to say, I'm thinking of applying to your program. I'd be really interested in, I'm interested in the research you're doing in your lab. Can we talk, you know, are you recruiting? And if so, would you be willing to discuss possible projects? Because sometimes the projects that are on the website, you know, when you actually talk to the PI, the one project maybe ended 3 years ago and the postdoc left, and that's no longer something that's going on in the lab. And the really exciting project is something that isn't on the website that I can tell you all about right now. And if you join my lab, that's the project I want you to work on. It's good to find those things out and not just rely on the information, you know, the stuff that was done 3-4 years ago that's on the papers and on the individual PI's website. So definitely look at individual research interests, and you know, and that takes some time to investigate, right? And that, I know that can be intimidating, but it's worth doing. Yeah, it's definitely worth investing a little time. Once you find something that really interests you, it's worthwhile kind of digging in and finding out more, so that when you talk to this prospective mentor, you have some sense of what they've done and the kinds of questions that they find interesting, and you can ask interesting questions on this. You'll impress them if you do that. You know, looking up rankings, you know, rankings can be you know, there are not necessarily good, reliable rankings out there, but it's possible to ask for advice, right? So if you will often find, can even informally, if you talk to a faculty member here in a research area that you're, that's relevant. So for example, if you talk to me and ask, what would be good places to do evolutionary biology of this type, I can give you some advice, right? I will know some research, there's these labs over in this program, and often they will be not the schools you necessarily would imagine, right? It's not the case that MIT is good at everything. It's not the case that Harvard is the best place at everything. You'd be surprised for particular areas. You might get, recommendations to go to places that you don't know about. That for example, you might not know that University of Indiana at Bloomington is one of the best places to do evolutionary biology, evolutionary genetics in the US, right? It's not. I'm not telling you Princeton and Harvard. I'm telling you Bloomington, Indiana, right? Maybe not the place you'd most like to live in, but a great place scientifically. Great scientists there for my particular area, and these answers will be true for different areas. I'm sure Greg can tell you about different physics departments for particular areas of physics that would be very highly regarded here and there. So don't necessarily rely on like official rankings in US News and World Report, because those who knows how those are constructed. Well, I know how those are constructed, and I don't trust the data. Let's put it that way.
Can I mention one thing?
Go ahead. Go ahead.
I want to echo that the college rankings are not accurate. There's a lot of self-correlation in that data. It's not effective, but it does give you a ballpark. The other is that many students have, especially if you're interested in research, you may have worked with a research advisor, and that research advisor may have given you a paper to read. Look at the citations in the paper that you were reading and see where those people came from, where those people are working, right? To give you a sense of what kind of places are doing the research actively that you're interested in.
Yeah. Great advice. I will sort of on a related point, which some general piece of advice that I would have. So, like Anne mentioned, that she's unclear at this point what program, exactly what field of research she would want to do. One general piece of advice would be, if you read some primary research papers in an area, and if you find yourself being really excited by what you're reading, like these are papers that you pick up and you don't fall asleep trying to read. If you read them at night, you actually find them really interesting. Doesn't matter what anyone else says. Doesn't matter what you hear people say that, oh, you should get into Alzheimer's because that's where the money is, or cancer is more exciting. Doesn't matter what anyone else says. What you find interesting. It can be something esoteric and difficult to, and sort of not something that you can explain to your friends very easily why that's interesting. If you find yourself reading primary research and being really interested, that's probably the field that you should get into. This is a kind of a general rule of thumb that may not always apply. Sometimes you have to read research that is difficult and kind of takes effort to kind of learn the principles that get you in there. But this might be a good general rule of thumb to find the general area that you're interested in. So take that advice if you want. But it's not a bad idea to find things that you find exciting, that you find yourself trying to explain to other people, and they look at you kind of weirdly because they don't get it. Why would you be excited about this? So think about that. So rankings, asking grad students is sort of good advice. Like if you're interested in a particular lab in sort of particular research area, particular department, it's good to potentially see if you have a way to talk to students in that program, because that can sometimes give you good advice. It relates to a point that's going to be made in the next slide. So I'm getting to the end. Oh, I'm sorry, I'm taking too long on this. I'll try to. Yeah, this is my last slide, so I'll try to wrap this up quickly. So a few general, reflections on the factors to consider when you're thinking about a program. It relates to what I was just thinking, that if you have a particular lab in mind, it does help. So if you, for example, have an interaction with that PI, maybe you have a Zoom chat with them and they tell you about their research, one thing you should do is ask them to meet their students. So ask for the contact of some students. It's very important to establish not just whether you can have a good interaction with the PI when they are controlling the interaction, but get a sense for how students view these interactions in the lab, and don't dismiss red flags. So sometimes you talk to individual students and you'll feel that there's something weird, there's some kind of a weird vibe in the lab. Don't just dismiss that. That could be a sign that that's not a good place to work. Whether the PI might be a very successful scientist, but not be a very good person to work with. This is definitely, I know many examples of cases where people join labs either as graduate students or as postdocs, and then have really bad experiences, partly because they ignored red flags, or they didn't even. There were no flags to be regarded because they just had one conversation with the PI, thought it was good, their research track record was good, and then they had a nasty surprise when they arrived because this wasn't good. So try to establish whether the PI is a good person to work with, and partly using information from students and postdocs, if you can talk to them, would be good. Financial considerations, definitely don't, consider that carefully, because the commitment to do a PhD, especially for a PhD, is long, and so it's good to plan and see whether this is a career path that would be sustainable for the duration of the PhD, and see what you need to do. Again, finding out from grad students in the program whether this is a good place to work in is worthwhile. And I think I will probably stop here and pass it on to Greg. So I think, do you want to share the presentation from your end, or do you want me to just keep changing slides?
Yeah, I'll share mine.
So I will stop sharing. Okay. And sorry, I probably took a bit too long, and then if anyone has a question now, I'm happy to answer, but I'll stay here until the end. And if you're still thinking about questions and prefer to talk at the end, that's fine too.
Yeah. Okay, I don't hear anyone unmuting, and so I'll just go ahead and we can have questions at the end. I wanted to add one thing to what Ricardo was saying as well. If you find that you're in sort of this abuse, you find that you have a garbage human being as an advisor, and you find that out in 3 to 6 months, it's okay to leave. Right, they're evaluating, your advisor is evaluating you, but that first 3 to 6 months, you're evaluating him or her, and you're not too invested to not try to find somewhere that you fit better. So don't put yourself in a position of making a 2-year mistake instead of a 6 months mistake. Okay, so I'm going to talk a little bit about how to reach out to professors, and before talking about some of the details, I just want to sort of motivate why you're doing this. So when you actually apply for grad school, you're going to be sending in a lot of materials, and that's going to involve a research statement and your grades, and that's going to go to a committee of usually 5 faculty members. all of whom have different research interests, and none of them may be your research interest. And what those two faculty members, what those five faculty members want is two things simultaneously. They want to make sure that you're going to pass the first rounds of classes, typically, and so that means that your grades need to be high enough. And the other thing they want is to make sure that you're going to be able to end up successful in research. The grades thing is actually not as hard to predict as the research thing, right? In undergrad, you're going to have whatever your letter grades are, and they can sort of normally expect that you're going to perform in a way that's similar to other students that have passed through there. But typically, it's much harder to predict who's going to succeed in research. One of the great ways to predict that someone will succeed in research, though, is if there is a faculty member at the institution that is interested in having you there. If that happens, that's really good news, right? If somebody's willing to walk down the hall and talk to these five people and say, I really do want this person to come to my lab, I mean, that's an enormous advantage to you. And so one of the best things that you can do in order to increase your chances is to talk to professors and hopefully identify someone that is A, interested in something that you're interested in, and B, looking to hire a student. Okay, those two things are not necessarily guaranteed in every department, but the only way to really know that that's the case is to ask them. Okay, and so everything that Ricardo was saying about researching the departments and don't automatically assume that the website is 100%, and I'm ashamed of my own website as well, and now I'm realizing I need to deal with that. But don't assume that just because you read something online or you read a paper from this person a couple of years ago that you know exactly everything that's going on. What you want to do is get in touch with them and try to start a conversation. And so that can be really intimidating. Like some faculty members seem really friendly, others though are very intimidating, and so it can be difficult to do this reaching out. Why am I not? Here we go. Okay, so the first thing to do, though, is, as we were saying, look at the look at the faculty profile page, look at their website, look at their papers. Okay, and let's see. Essentially, yeah, what you need to do is look through these departments and just try to pick out some names and contact information, and just send them emails. Okay, so I'm going to talk a little bit about how to construct this email, but generally speaking, the very first step in figuring out what to do is to actually look up these names and contact information. Take notes about why you're interested in them in particular. Okay, so actually write down, oh, this person is interested in computational biophysics. And I am interested in trying to understand Alzheimer's or something like that, protein aggregation. And so I want to ask them whether or not they're looking at aggregation problems or something something along these lines. If you have a PI, if you're working in a research lab, one of the best resources you have is a recommendation from that PI, right? So once again, so odds are your PI, if you've been working in a lab, your PI is probably going to write you a letter. If not, that sort of reflects that they weren't very happy with you, and that's not great news. And so with any luck, you're going to be receiving a letter from your PI. A phone call is much more valuable. If your PI, if you say, oh, I'm thinking about applying to UC San Diego, and your PI says, oh, one of my former postdocs from my group from 10 years ago is a faculty member there. Let me give him a call. Like, that's enormously valuable. And so do talk to your PI about whether or not they have suggestions and whether or not they can help with these contacts. Okay. Yeah. So when you write this email, you do want to sound professional. You do want to make a good first impression. Okay. There's a few things that are listed here that I'm going to talk about. But one of the most important things, and I receive these emails probably, I don't know, 10 times a semester, asking whether or not I have whether or not I'm hiring, and about 75% of them begin with "Dear esteemed professor." And that is the least useful thing that you can possibly write. And the reason why is because I bet you don't know my name. I bet you sent that email to 400 people. And so I delete it almost immediately. Okay. What you're trying to do with this letter is give an impression that you are an intelligent professional that is interested in the work that I am doing, and you're inquiring to see whether or not it is possible for you to work with me. Okay, so definitely, don't send emails from silly email addresses. So whatever this Epic Gamer 69 thing is, I mean, I personally wouldn't take too much offense to it, but it would, if I did notice it, I would think it was strange. Let's see. So that's something to include. It's also important to get my name right, to get the university right. Like if you're going to be writing multiple versions of this, it's really easy to accidentally screw up and send an email to me saying, dear Dr. Whoever, that's not the right person and not the right school. So be careful when you're writing these things. Introduce yourself. So let me know who you are, right? So you're graduating in a couple of years and you're just looking to see whether or not the department that you're at the University of Houston is good. Whatever your goal is, make sure that I know who you are before you start asking me questions. Okay, and so this would be this includes classification. So whether or not you're graduating, where you're coming from, so the university, research interests, and these sorts of things, right? And so this optional item of the mutual contact once again really strengthens. If I get an email from a student saying that my former graduate advisor recommended they get in touch with me, I will definitely open the email, right? I'll definitely, almost certainly reply. And then ask questions. So asking questions is a little bit, can be a little bit risky, solely because if you ask off the wall questions, or if you ask a litany of questions, I'm less likely to reply, right? And so if you ask me, so I've never received this question in an email, but I have received this question from a student in office hours: who is my favorite scientist? And I think that's a fun conversation to have, but a deeply strange one to include if you're trying to appear that you're a professional, right? Try to keep things on topic, on point. What about my research is interesting to you, and whether or not I can help you understand a little bit better what it is that I need from my students. Let's see, yeah, so that's don't bombard. So also don't bombard with a thesis. Like I am interested in speaking to students, but everybody's time is valuable. And so if you give me a 10-page thesis about what you're interested in, or alternatively, if you send me a dozen questions about the details and minutia of the day-to-day life in my lab, I'm much less likely to reply to that request. Right. The most important thing to ask, though, I think, is about funding, because what you want, if you find that this person is doing interesting things, and they're also, you want to know whether or not they're taking students, because so the way that it works, at least to the physics department here at the University of Houston, your first year, you're guaranteed a teaching assistant. So if you're accepted into the program for the PhD, that first year, your PI, I can take you on as a student for that first year, and I don't have to pay a dime. After that, though, there's an expectation that I'm paying almost all of my students. We have to negotiate for who gets a TA or something like that. But I may not have the money. I may not have a grant, or alternatively, I have a grant and there is a student that has already paid off of that grant, right? And if I'm in that position and I can't commit necessarily to funding you. And so if you speak to multiple faculty members and you find one cannot commit to funding you and one can, that's not the be all end all, of course. Like there are multiple things to consider whenever you're choosing an advisor, but it matters a lot that you're going to get paid, right? And so don't discount that is an important factor. Okay, so asking Structuring an email something along these lines is good because it does a few things. It introduces you to the faculty member. It lets you clarify to the faculty member that you're a professional, intelligent person that is at least generally aware of what that person is doing. It gives the faculty member an opportunity to reply to you, to tell you what they're doing, what they're actually looking for, and to tell you whether or not they can pay for you, right? Another reason to do this is because when you write your research report, you can include a sentence or even a paragraph talking about how you're really excited about protein aggregation, and you would talk to Dr. Morrison, and he's interested in protein aggregation as well, and maybe I'd be able to work with them. Because those 5 committee members that are going to be evaluating you, they can ask me whether or not we had a conversation, whether or not I think that you might be an okay student. Though I might even be invited to interview you directly during this process, right? And so there's a lot of advantages to messaging a faculty member. I think the next is, yeah. So this is a specific example. So I think that this, yeah. So this is Alejandro, and I believe that Alejandro, this is the specific example. Maybe he can clarify, but I think this is probably the email that he actually sent to his current advisor whenever he applied to UH. Is that accurate, Alejandro? I'm not sure if you're wrong.
This is email I sent to a professor at Cornell.
Oh, okay.
Yeah.
Okay. But it's a very good example because essentially it's structured the same way that we were just talking about. Talk about yourself briefly, ask some clarifying questions about the person's research interests. And then question 3, importantly, is the money question, right? Are you looking for someone? And that's really key. And so always make sure to include that, right? And it's a professional email. Like it's you sign off with thank you for your time, or best, or sincerely, something along these lines. So I just keep it professional. But something like this, when I receive an email like this, often I'm able. Often I read this and I would try to reply to this. And in my current situation, my reply would often, so I don't have the money for an additional student right now. And so my reply would include that information. But I would also say that, I would encourage you to apply to UH because, it sounds like you're interested in this, and we have another faculty member who's doing that, right? So, so there's still a lot of information that you can get from this. And this is the reply. Okay, and so here are some details, here the faculty member. If you look at the last sentence, it doesn't look like the faculty member was very specific about whether or not he or she individually had the money for a student. I would usually try to be clear about that. But I would also include this information about TA being the first covering you for the first year, right? But this is the kind of reply that you might be able to expect. One important thing to point out is that some faculty members are less nice than others, and some faculty members are very busy people. And so you may send a bunch of emails out into the void and never hear back from anyone. And that doesn't reflect badly on you. It just means that if some of us receive 100 emails a day, and so particularly if you're emailing during certain times in the semester, it is just impossible to keep up with the steady stream of requests. And it's very easy to get lost. This email can very easily get lost. And so don't take it personally. If it's someone that you're specifically very interested in working with, it's okay to send one follow-up email. Don't be pushy about it. Give it a couple of weeks and politely say thank you for any time that you can give me as a response, and that's it. If they don't reply the second time, they're just not going to reply, and it's not because you're a bad person. It's because they're a very busy person, typically. Maybe they're a bad person, though. Maybe they're one of the garbage humans. So, okay. What time is it? So we're actually pretty much at time. I think this is a good place to pause. Oh, there was one other thing that I wanted to mention. It is very time consuming to do this process, right? You have to read a bunch of websites, then read individual pages for faculty members, and then sort of build build a list of things that you're interested in, especially if you're not sure what you're really looking for. It can be really hard to build this list. And what I want you to know is that it is to your advantage to email a faculty member. If they get back to you, it helps. It is not a problem for you to apply without going through this process. Don't give up on grad school if you're intimidated. Don't give up on applying for grad school if you find this process intimidating, or if you're just too swamped and you can't do it. You could still get in, but any effort that you put into this will potentially pay off big. So it's worth the time, but it's also not something that is mandatory. If you can't do it, don't give up. So yeah, go ahead.
Let me just add something to this. So this is also, I mentioned, perhaps I mentioned that I have some experience on this because I used to be the graduate chair in our department. So I oversaw the process of graduate admissions. And I want to really emphasize what Greg said. This is one of the most common mistakes I saw from people applying locally to our program. Applying from within UH was not, or sometimes applying from Houston or near Houston, was that clearly they hadn't done due diligence on this site, right? Sometimes you can have a strong application in other respects, like you have a good degree, you have some research experience, you might have done a lot of things right, but it can stand out that you didn't put any work into this part. One example that can happen is you can apply to work with a certain person in a certain area, or sometimes say, I want to work in this area. And then that area doesn't exist in the department, or that area exists in one lab in the department, and that lab isn't taking students. And that's exactly the kind of thing that's a wasted application, which if you had approached this PI and said, look, I'm really interested in your research, can we talk? Are you taking students? Do this extra step. You would have found out sometimes that they are applying to work with the person. That person has left. They're still on the website, but they've taken a position in another department, right? So there are these things that you can just find out a lot more by taking this additional step. This is really important. I mean, you can apply without it, but you're often shooting yourself in the foot. It's very good to do this. Not least because you're establishing contacts that can be very valuable in the long term. So sometimes you might establish let's just make one quick additional point as you think about questions. These are all very interesting, very good interactions to have, and it's perfectly okay to have interactions like this with more than one faculty at different programs, or sometimes in the same program, with the understanding that you can only choose one, right? It's fine to talk to several of us and say, look, I'm really interested in your program and I'm interested in your research, but I've also applied to other programs. And at some point, if you get 3 offers, you can only go to one lab. But having these interactions with individual faculty can be very useful. Even if you don't join their lab, you might meet them again a few years later at a conference, and these are worthwhile. They take efforts, but they will definitely strengthen your application. So, any questions? Let's open this up to discussion.
Yes, I have a question. I joined a bit late to the meeting, so I'm sorry. But so I don't know if you guys covered this already, but is there like any sort of consensus on, now that since the GRE is no longer required, should we like still take it or worry about it even?
I can say something quickly about, so definitely find out whether it's required for the institution you're applying to. And this is not Not every institution has dropped it. Not every program has dropped it, but many have. If you find yourself, let's say you really like 5 programs and a couple of them do the GRE, maybe it's worth taking the GRE as well. I don't know, Greg, I don't know if you have a different advice, but it's...
So, yeah, I am of the opinion that the GRE is a completely useless indicator in certain cases and a useful indicator in one case. I would actually recommend taking the GRE. The reason why is because in an application, if you include a GRE, you can include your GRE score even if it's not mandatory for that department. Anyone that does really well on the GRE is likely a smart person, right? Anybody that does badly on the GRE, I can say absolutely nothing about, right? And so if you do, because basically if you have a bad day on that particular day, you're going to do poorly on this exam, but that has nothing to do with your intelligence, right? Life is more complicated than that. So doing extremely well, though, is a great indicator that you're going to at least pass the classes, right? And it definitely elevates your. Some people pay attention to this very closely, right? So there are 5 people on this committee, and at least one of them is a grumpy old guy that just wants it done the way that it was done in 1965 or whatever, right? And so. Well, that was my experience in physics. I don't know, when Ricardo was on the committee, maybe everyone was a little more progressive, but essentially some people can care about this even if the university doesn't require it. So I would take the GRE, just the general GRE. I would personally not bother with the subject GRE because it's so rarely required and so very specific that it's rarely going to help you. But if you score really high on the general GRE, you can include that information even if it's not required, and it lifts your application up a bit more. And if you do really badly, well, it's not required, so don't include it. So I would give it a shot.
I will add. I will sort of add just one comment. So in along the same lines, it can also be useful if you have. If you're insecure about another component of your application, for example, your transcripts, right? So if you apply with a very strong GPA from UH, say, to another program, that's, maybe at that point, and if the program doesn't require the GRE, maybe it's not necessary to if the rest of your application is very strong, maybe it's not strictly necessary. But it can be good as along the lines of what Greg said. It can be good as a complement. Mm-hmm. If you show, look, I've scored really highly in this, even though even though I had a bad semester in my undergraduate, and I didn't go back and retake those classes to get a higher grade. It's up to you, and of course I understand that there are some financial constraints in this too. It's not, it's you are spending money, and the whole thing, it costs money to send it to multiple institutions. It's tricky, but it is, it's something that it's worth considering, even though it's not required. I'm perhaps a little. On balance, I would probably say if it's not required, don't bother. But I can see Greg's point. It's sort of and he's right so I'll just give you as an example. So I was graduate chair when our department dropped it. I was advocating to drop it from the requirements. In the committee that does the evaluations, this was not a universal opinion. There were several members that did not want to drop the GRE from the requirements. Me and the chair decided that this was what we wanted to do, and we just did it, right? But some members of the committee did not agree, and so they would be the examples that Greg mentioned. There are some people who, if they see the GRE and it's a good score, they will be pleased about it, even though they're supposed to not use it to make a decision. So, Yeah, sorry if that answer was not was confusing, but it's not an easy call.
Yeah, there really is no right answer, and it really does. I mean, if you got all straight A's, maybe there's no problem, but it really is the case that it's a number, and so the question is, can you get a high number, and do you need it, basically? And but it can help with some people, even if it's not required. Yeah.
Thank you. That was some really good information. And that did answer my question. Thank you, gentlemen.
Yep.
Good.
Are there questions? I'm not sure how to get my chat screen up. How do I find chat?
Yeah, there's nothing else yet.
No? Okay.
Yeah.